Let's add a new file, vpc.py, to hold the networking resources. It will be construct, so let's copy these lines. Pass here. We're going to use tfvars as well, so let's copy this one. Then let's input the VPC submodule. Put VPC. Let's add a class network inherits from construct. And the next we'll define the danda init. Passing self as a scope construct of type construct. And name type string. Next, initialize the super. Passing construct and name. Now we can define a VPC object. Self VPC equals VPC. Now the scope, of course, followed by name and many other parameters. This is the VPC submodule. We input from VPC here, and this is the class. Let's check for the required params. Scope and ID, path. This is probably already the methods. Okay, it is indeed. So strictly speaking, the scope and ID are the only required attributes. This VPC class implements this HCL resource. Let's have a look. Is there anything exciting here? Must provide the CIDR, the instance tenancy, so the usual. Let's check how to specify those in the class. Here's the CIDR block and the instance tenancy here. I will also add the DNS settings to not rely on the defaults. Let's do just that. Okay, let's see. Where is the CIDR block? It's a string. CIDR block equals. I'm going to assign its value from a variable. So let's add to tfvars. So CIDR VPC. And assign it with this string. So back to the vpc.py, we'll need to add the vars object here. Vars, passing self and network as its ID. Now vars can be referenced here. Next, the instance tenancy. Setting it to default, followed by the DNS params to be set to true. Support equals true. And this is it. This is how to set a basic VPC. Let's add VPC to the my stack. Start by inputting the construct from VPC input network. Now create a VPC object here, self and network as its name. Great. Okay, let's add an output for this VPC. Output, passing self and VPC value equals vpc.vpc.id. So this VPC is for this object and this one is for this object. Now let's save it and check for any syntax errors. Synth. We've got an error. There is already a construct with name network in construct. And the error relates to this VPC construct. All right, let's check the construct. An ID and a scope must be unique, but the network string is used twice in this network class. So let's change this one. Save and give it a try. TF synth. Fantastic. No errors this time. Great. We can try to deploy this tag. Deploy. Let's see what will happen. I expect a new VPC object and 2 outputs. There you go. Here is the side block and the outputs. Great, it worked. Next, I'm going to add 2 private subnets to the VPC. I want to add a subnet into 2 availability zones in the region. So the AZs will be US East 1A and US East 1B. Let's add the zones as the list by mapping the zones A and B to the region. We'll use lambda, accepts AZ, outputs vars.region, concatenate it with AZ. By the way, vars shouldn't be the class variable. Let's fix it here and check everywhere else. Great. The map returns an iterable, so need to cast it to a list. Okay, save it. So the AZs list holds 2 availability zones. We can add subnets now. Let's explore the subnet submodule first. This is the subnet submodule. Input from subnet. This is the class. Got this mandatory scope and ID. Let's check for any additional required params. Scope and ID, and then the VPC ID is required too. Okay, these are already methods. This class has 3 required attributes: scope ID and the required VPC ID, which we don't know before the code is synthesized. I'll use this CIDR block to assign an IP range for each subnet, and I want to use Terraform's built-in CIDR subnet function. I'm adding private subnets, so I'm going to set this map public IP on launch to false. Okay, now we know how to use the subnet class. Let's try it. For each AZ in the availability zone list. Okay, but first I'm going to input the submodule, subnet. Okay, now subnet instance here, self followed by name, brief sub, concatenate it with the AZ, which is already a string. Next, a VPC ID equals self.vpc.id. This is our VPC object, and the availability zone. Okay, next, let's set the public IP on launch to false. And now I'm going to set the sub's IP range using the CIDR sub built-in function. The CIDR subnet function accepts three parameters. Prefix, this is the VPC CIDR. Then new bits denotes how many new bits are added to the VPC CIDR mask. Our VPC's mask is /20 plus 4 new bits results in /24 mask for a subnet. And the netnum param sets the subnet's index. HashiCorp provides a set of built-in functions to use. Those functions are used when one needs to calculate values based on runtime values that are unknown before the config is applied. VPC ID isn't known before the config is applied. Let's check this usage example. So the fn object must be imported, and then it can be called with a method. Okay, let's give it a try. So the CIDR block equals fn.CIDR. We need to import the fn object to use it first. Fn. So the CIDR subnet function accepts three parameters. First is the VPC CIDR. Let's add it. Followed by the new bits and the sub's index. And the index will be AZ's index of the element. Let's save it. Okay, we've got the fn construct imported and the subnet module here. This is the function to calculate the IP range for each subnet with all the parameters it needs. Okay, it's looking good. Next, let's check for any syntax errors. Let's run cdktf synth and see what is happening. Okay, we've got an error. Network object has no attribute VPC. Let's have a look. Is the error due to the order of appearance here? Can only reference VPC after it is defined, can we? So let's do this. save it and give it another try. cdktf synth. It worked this time. Great! Next, let's create an empty list to store all subnets in it. And append each subnet to the list. Okay, this looks better. Now we have the subnets all stored in the list. Let's check for errors after this change. No errors, great. So we've got a list of subnets with a subnet per AZ, and the subnets range is calculated by this function. Great. The VPC object is already in the myStack class. Thus, the next deploy will create 2 subnets. Let's give it a try. cdktf deploy. Okay. 2 subnets have appeared. First with this range, and the second one. Fantastic. Okay, let's add the subnets to the state output. We can iterate the subnets list. Then VPC subnets. Now terraform output. Self, and give it a name. Concatenate it with index. Okay, then this one has to be string. The value will be VPC subnets element .id. Okay, let's see what happens now. Now cdktf deploy. Okay, I'm expecting 2 outputs to be added to this state. And there they are. Change 2 outputs. The 2 outputs, both private subnets. Great.